Our Sun. Scenario 1. Something strange just happened now. Every TV channel, the news, they're all talking about a black hole that came closer to us, on the spot where our sun used to be. You can even see an accretion disk, and the background of the sky looks kind of distorted, which means it got really close. Normally, black holes are so far away that we can't see them with the unaided eye. You can't even see them with a telescope directly. What's it doing here so close? And where's the sun? Did the black hole swallow it? The sun used to be in the center of our solar system, far enough not to burn us, but still close enough to give us light, warmth, and beautiful scenes when it rises in the east and goes to rest in the west. Hey, this one even rhymes. Well, it gave us life. The most massive body in our solar system contains 99.8% of its total mass. It's so wide, you could fit more than 1 million Earths inside of the sun. Maybe our sun turned into a black hole, but it's way too early for that to happen. I mean, that's how they form, when enormous stars come to the end of their life cycle and explode, which is called a supernova. They end up collapsing on themselves, becoming very small. It's a tiny size and a huge mass. That's what makes black holes' gravity so strong, and even light that comes too close can't escape. And all the stars in the universe are shrinking and will disappear at some moment. Our sun loses 4 million tons of mass every second, and eventually, the only energy left in the universe will be generated by black holes. A black hole is surrounded by dust, gas, and radiation. The radiation is very dangerous, so we hope our planet won't come near it. Our solar system doesn't have light anymore. No light and no heat either. So even Mercury and Venus will probably get covered in ice pretty soon, not to mention Earth. Do I need to say nothing will survive this new ice age? The only salvation might come from the accretion disk that spins so fast it generates heat, but that's too many chances to take. Still, at least if the black hole has the same exact mass as the sun before it, all the planets will remain in the same orbits, Earth included. But if it has a mass bigger than our sun, which is something our scientists are currently trying to figure out, then bye-bye, solar system. It was nice knowing you. Scenario 2. Oh no, what's happening? It was supposed to be a nice sunny day, but now you see darkness descending so abruptly. How come it's night, yet the clock says it's 2 p.m., and the moon looks different? The TV reports say our sun is gone. And due to some mysterious events, the moon is not orbiting the Earth anymore. It's in the center of our solar system now. We don't have much time left. Since the sun is not in the center of our solar system, we now have 8 minutes and 20 seconds to become aware of it. It may take millions of years for the sun's energy to travel from its core to the surface, but 8 minutes and 20 seconds is exactly how long it takes for sunlight to reach Earth. The light takes a journey across 93 million miles, which is the distance that separates us from the sun. We're not in the habitable zone anymore. The habitable zone is the distance from a star, in our case, the sun, at which liquid water could exist on the surface of a planet. Now that the sun's gone, its light won't reach us anymore, and our planet will gradually become a frozen, lifeless rock. Who knows if we'll have enough time to come up with some technologies that would provide us with the solar energy we need to sustain life on Earth. If not, well, millions or billions of years later, scientists from some other civilizations would explore it, trying to find evidence if life ever even existed there. It would be the same as we do with Mars and other planets in our solar system, trying to figure out if they've always been lifeless or if there might be a sign that some organisms used to live there. Something else, also vital for our life, travels at the speed of light. Gravity. Without the sun, for roughly 8 more minutes, the planets would continue circling the empty center of our solar system until the clock ticks and they finally drift somewhere into an unknown direction of outer space. Our moon doesn't have a strong enough gravity to keep us in place. It can't shine so brightly to give us warmth and support life. It's so far, we can barely see it now. Without the moon that peacefully travels close to our planet as it used to, we can see tides are getting lower incredibly fast. Oh, and it's becoming really windy. Winds are so much stronger and faster now. When things were normal, our planet sat at a 23.5 degree tilt, which is the reason we had changing weather and seasons. Now the tilt is so extreme, it's getting very cold, very fast. And our time is almost up. People are screaming, everyone's in panic. We still have maybe 1 minute left until we sink into eternal darkness. Scenario number 3. We're not sure what exactly happened and how the life we carelessly lived yesterday came to an end. No one could predict it, but it seems that, out of nowhere, a giant neutron star took the spot where our sun used to be. It's not something we'd recognize on our own. We just noticed something was different, and the sun kinda got smaller and weirder. The rest we heard on the news, and no one knows how it happened. Maybe our sun is somewhere behind the neutron star, or the star pushed it out of our solar system and into an unknown direction. A neutron star is the densest space object we know about. It has almost twice as much mass as our sun, but it's all squeezed into a star only 10 miles, 15 kilometers, across, which is about the size of a city on Earth. A neutron star forms when a huge star runs out of fuel. It collapses in a big explosion. Its very central region, the core, collapses, which is why every electron, negatively charged particle, and proton, positively charged particle, crush together into a neutron, which is either uncharged or neutrally charged. We're in a very tricky situation now, basically waiting for our end to come. This neutron star has gravity 2 billion times stronger than the one Earth has. This means our new sun will pull all the planets in our solar system towards itself and eventually destroy them. It's already started. For the first time that we know of, the planets are leaving their stable orbits, attracted by the powerful force of the neutron star. It's becoming chaotic pretty fast. And it won't stop there. A neutron star rotates more than 700 times every second, which is incredibly fast. Our sun rotates once every 27 days. So, after it destroys all the planets, including us, this star will continue whirling throughout the universe at about 1/5 the speed of light. Maybe it will slow down and fizzle out with time, but maybe not. After thousands of years, many neutron stars begin to slow down and blow out. But that doesn't always happen. If it meets another star, it will orbit it and start to feed off its atmosphere until it collapses at some point and turns into a giant black hole. Our sun was going to burn out anyway. Until the neutron star showed up, the sun was 4.6 billion years old, which was about halfway through its lifespan. It had already burned off about half of its hydrogen stores and had enough supplies for another 5 billion years. It was eventually supposed to end up the size of the Earth. After running out of fuel, it would have simply collapsed. It would have retained its enormous mass, but its volume was going to be similar to that of our planet. No sun, no life, so the result would have been basically the same. But this way, it would have been a slow process. Who knows if humans would even inhabit this solar system in those times? But with neutron stars, things move towards the end pretty quickly, and it's way more chaotic. If the neutron star was going crazy somewhere far away in another galaxy, we'd only see it in the shape of a distant flashing light that we call a pulsar. But this way, boom! What would happen to us and our planet if it became as big as the sun? The diameter of the Earth is 8,000 miles. Crossing it is like driving back and forth across the USA 3 times. That doesn't sound like much, right? Well, how about repeating this journey 305 more times? Just imagine the gas expenses. This is the diameter of the sun, about 865,000 miles. Compared to our Earth, the sun is unimaginably huge. So what will happen to us if we catch up with it? There are 4 possible scenarios, depending on what we mean when we say the size of the sun. Scenario 1. The Earth becomes as large as the sun, but its mass remains the same. A colossal planet with the mass of a teeny tiny Earth. First, say bye-bye to gravity. The more massive the planet, the stronger its gravity is, and vice versa. Such a lightweight planet simply wouldn't be able to attract anything to itself. Gravity creates all the heavy substances. Everything, from pebbles to entire continents, is held thanks to it. I believe you've already guessed what would happen without it. we'd all turn into dust particles. Yes, the Earth simply becomes a dust cloud. Oh, and to add fuel to the fire, the gravities of other planets stretch us to the sides, leaving no chance to collect our planet back together again. This scenario doesn't look very good, does it? By the way, even if the Earth somehow remained a planet, life couldn't have originated on it in these conditions. There would have been a considerable distance between the center of the Earth and its surface. And remember, the planet's mass is minimal, so no gravity. It just wouldn't be able to hold the atmosphere. And without the atmosphere, living organisms cannot develop. Not like it would have mattered. The Earth now is a cloud anyway. So now this cloud, weighing about 10 times heavier than Jupiter, is gathering in space. As a result, it collapses and turns into a star. Say hi to the new sun. Scenario 2. This works both as a separate scenario and as a result of the previous one. The Earth becomes as large as the sun and gets its mass. Now we have two suns. We become a so-called binary star system. You know what that means? It's time to destroy our entire solar system. Imagine having two centers of mass in one system. The planet's orbits become unstable, perturbed by such a sudden change. Once they get closer to our ex-Earth, they collapse immediately, either from tidal forces or the ex-Earth's impact. Yes, even gas giants. Looking at you, Jupiter. Do you know which one survives and finally gets its revenge on us? Pluto. It would probably be the last remaining X-planet in the entire system. It's too far away to notice any changes, except for an increase in the mass of the center of the system. So Pluto's orbit comes closer to our two-star system, and that's it. The Earth and the Sun would have to accept that Pluto would be their only friend now. The protoplanetary disk that formed our system billions of years ago doesn't exist anymore, so no more planets can be created in our system. That's all well and good, but what about the Earth itself? What would life be like? Let's see. The nights and days now last longer because of the increase in the Earth's rotation time. There is probably a significant temperature drop in the North and South poles. Even on our current small planet, they get sunlight scarcely. So if the Earth's size increased, the area of the poles receiving sunlight would decrease even more. On a positive note, there's a lot more space now. No more overpopulation. The planet's size is so huge that it would take you years to get from one point to another. Yeah, if you think about it, we'd probably be very lonely there. But hey, who knows? Maybe rockets would become our primary means of transportation. Yeah, that would have been cool. There are many vast uncharted areas that no human ever saw or visited. We also wouldn't know about the existence of many different civilizations and tribes. Centuries pass, and many of us go away without ever meeting other people or learning about them. And that's if we can walk at all. Our bones cannot support our weight with such a considerable gravity, and our hearts have to work twice as hard to keep us alive. The birds can't fly anymore. Nothing can, precisely. All the existing trees fall down, and the new ones grow very close to the earth, like grass. Talking about the trees, how is our ecosystem doing? Well, not good. If we don't appreciate the environment on our small Earth right now, imagine what would happen if we had such a massive space at our disposal. I even assume that our tons of garbage would have overpowered even those endless supplies of trees and clean water that we would have in our new large home. Our machines and robots have to be huge to do at least something now. That's because even ordinary farms now are the size of the US states. I also assume that it would be much darker than we're used to. The Earth is so small now. Imagine what would happen when our planet becomes the size of the sun itself. Less sunlight means that we'd probably need an artificial sun. Also, the temperature differences on the planet's surface would be huge. If you're surprised, you probably underestimated the size of the sun. It's almost 110 times larger than the Earth. our new Earth's equator equals our current Earth's 35 equators. Oh, and remember Pluto? Well, it's our only moon now. The first one would have probably crashed into us a long time ago, making us share the fate of the dinosaurs. In that case, all the water would likely evaporate from our planet. Anyway, there are thousands of bad possibilities, but let's just move on and focus on something good. Scenario 3. Same thing, but the Earth retains its density. Now this one is interesting. We're no longer a planet. We're a star now. In fact, we became even more massive than the Sun. Our planet now has a 3.9 solar mass because we need to balance our low density somehow. In short, it would be almost the same as in Scenario 2, but with more interesting long-term consequences. Since our Earth became 4 times as massive as the Sun, it would have burned its fuel quicker. Then it would evolve, and depending on the mass of its core, it either becomes a supernova or just blows off its outer layers to form a planetary nebula. If it goes supernova, the Sun that was so close to us blasts, and now there is just our ex-Earth, a lonely ball with a teeny tiny diameter of 12.5 miles. We're a neutron star, that is, a star made of degenerate neutron matter. That thing is ultra dense and spins very quickly, so you'd better stay away from it. If the Earth becomes a nebula, the Sun collects all the dust and adds it to its mass. Now we have a slightly more massive Sun and a white dwarf. The time passes, and Grandpa Sun lives out his life. It becomes a red giant after depleting the hydrogen in its core. It starts expanding and leaves its material, mostly hydrogen, on the white dwarf. That's us. When the matter reaches high enough temperatures and pressures, nuclear fusion happens. We become a nova. Yay, we're a star again. A lonely one, but a star nevertheless. So what happens next? You see, a star is a battle of opposing forces. One of them is gravity, which tries in every possible way to compress the lead into a small ball as much as possible. The second is a pile of fuel in the star's core, which, while burning, forms tons of energy and substantial hot temperatures. As long as these forces are in balance, the star lives. But when the star's fuel runs out, the star cools down. The pressure inside it drops. This means gravity has won. It squeezes the star with all its might, and as a result, the star goes, hooray! In just 15 seconds, the brightest light you've ever seen in your life flashes, and our ex-Earth goes supernova, leaving a stunning nebula behind. Anyway, don't worry. It's actually impossible for a rocky planet to be the size of the Sun. Only other stars can be that large. But wait, why is our Earth so small while the other planets are enormous? Do they just keep growing, or do they stop at some point? The more mass you add, the more compression you get. As planets become more massive, the gravitational compression increases. They stop growing when their mass reaches roughly 1.7 times that of Jupiter, or 540 masses of the Earth. After that, adding more mass to a planet will make it smaller, because the compression becomes stronger. In other words, our little thought experiment is impossible.
So, what's going on with all the news about the Sun? Some say that the Sun is getting angry. Well, what does that mean exactly, and should we be concerned? Frankly, yes, we should be concerned. It's generally not a good thing to get too much sunshine. The ultraviolet component of sunlight is harmful to the skin. That's why humans have adapted a spectrum of skin pigmentation. The more sunlight there is to protect ourselves against, the more pigmentation we need. Big floppy hats and, of course, bottles of high SPF oil-free sunscreen help too, especially for fair-skinned people. But what is planet Earth going to do? First, let's get a good estimate of just how angry the Sun is likely to get. The Sun usually goes through an active-calm-active cycle every 22 years, with highs and lows occurring every 11 years. Why that happens, no one knows, it just does. There's probably a reason, but scientists haven't figured it out yet. They do know that, with each cycle, the sun reverses its magnetic poles. That in itself is pretty astounding, especially when you consider that Earth hasn't reversed its magnetic poles in the last 600,000 years. Lately, the sun has been extremely calm, the calmest it's been in over 100 years in fact. That's unusual too. The active-calm-active cycle has turned into an active-calm-calm cycle. But that's changing, and it's why we are notifying Brightsiders about what to expect in the coming few years. The terms calm or active or angry refer to the amount of high-energy radiation that the sun gives off. Thankfully, the amount of visible light the sun gives off doesn't change very much. That would be a serious problem. If the sun were to get just 6% dimmer or brighter, the Earth would either freeze or fry. Observing sunspots is the easiest way to measure how active the sun is. The more sunspots that are visible, the more active the sun is. A graph, known as the butterfly diagram, tracks the 11-year period of sunspot activity. The butterfly diagram shows how sunspots disappear regularly from the surface of the sun and reappear regularly in other locations. NASA predicted that the present cycle of solar activity would be calm, like the previous one. But it's starting to look like that is not the case. Presently, we are in solar cycle number 25. That's the 25th 11-year solar cycle since 1755, when record-keeping began. This cycle of solar activity is expected to peak in 2025. The sun has already exceeded the number of sunspots NASA had predicted. So, it doesn't look like this solar cycle is going to be a calm one. It looks like we are going to have some very active sun-blasting radiation on Earth for the next several years. In early February 2022, 40 out of 49 SpaceX communication satellites in orbit above the atmosphere were destroyed by an explosion on the sun. High-speed electromagnetic plasma gas from the sun, known as solar wind, caused the Earth's atmosphere to compress, and Elon Musk's satellites lost their orbital integrity and crashed back into Earth. Sunspots look like dark spots on the sun, but they aren't dark. They're just not as bright as the surface of the sun. To get a better idea, take a lit 25-watt light bulb and hold it in front of a lit 100-watt light bulb. The 25-watt light bulb will appear dark. That's the same way it is with sunspots. Sunspots on the surface of the sun almost always come in pairs. This is because sunspots are magnetic storms in the plasma gas of the sun. One sunspot will be magnetic positive, and the other sunspot will be magnetic negative. Between the two sunspots, which can be many times bigger than the Earth itself, there flows an electric current that carries a fiery arc of ionized gas with it. Solar flares are something else we should be concerned about. They are powerful electromagnetic explosions on the sun associated with sunspots. As the superhot plasma gas on the sun churns and twists, it also twists the magnetic field lines in the sunspots. When these lines snap, a powerful explosion releases X-ray and gamma radiation at the speed of light. Visible gases are also released. Solar flares have a classification system according to how powerful they are. X-class solar flares are the most dangerous. This type of solar flare can cause radio blackouts across Earth and harm satellites, astronauts in orbit, and even passengers on high-altitude airplanes. M-class solar flares cause spectacular aurora at the North and South Pole areas on Earth, while C-class solar flares have almost no effect on Earth. But solar flares are not the biggest explosions on the sun. CME stands for coronal mass ejection, and these are much more massive than solar flares and more dangerous when they're headed our way. As the name indicates, coronal mass ejections are explosions that originate on the sun's corona. They hurl millions of tons of hot ionized gases outward from the corona. The word corona is derived from the Latin word for crown, and it's the layer of thin bright gas around the sun's surface. The corona of the sun is much hotter than the surface of the sun. The surface itself is about 10,000 degrees Fahrenheit, but the corona is somewhere between 1 to 2 million degrees. The why and how the corona is so much hotter than the surface of the sun is another major mystery that scientists have yet to completely work out. A recent theory claims the corona is heated by sound waves and the sun's nuclear reactions make a lot of noise. Project GONG, which stands for Global Oscillation Networking Group, was set up on Earth to monitor the sound waves on the Sun. Cool, huh? Turns out the Sun is ringing or oscillating like a bell. And we have 5 observation sites across the globe. One in India, Australia, one in the Canary Islands, one in Chile, and one in California that keep a constant watch over the 10 million sound waves moving on and around the Sun. Now that the Sun is entering an active phase, we can expect to see more powerful CMEs heading our way. The gases expelled by the Sun are ionized and stripped of electrons by the intense heat. This causes them to form a proton storm that can travel through space at speeds of around 500 miles per second. These positively charged atomic nuclei will mostly be blocked or deflected by the magnetic field that extends around Earth. Our atmosphere is no help against a proton storm, although the last mile of air above the surface of the Earth stops the harmful X-rays from solar flares. The particle wind from the Sun can only be stopped by Earth's magnetosphere. We can look forward to some spectacular aurora around Earth's magnetic poles, and it's very possible that these aurora will extend down to the mid-latitudes when the Earth is moving through a coronal mass ejection. Currently, the United States has a space probe headed for the solar corona. Because the corona of the Sun extends outward for many millions of miles, the Parker Solar Probe, as it's called, is cruising 3.8 million miles from the surface of our star, or about 1/10 the distance to Mercury. The probe is experiencing temperatures of 2,400 degrees Fahrenheit, but it is also kept at perfect room temperature. A 4.5-inch thick carbon composite heat shield protects the telescopes and magnetometers in the probe that measure the intensity of the solar wind. The 5 antennae that protrude into the coronal gases are made of a niobium alloy, which can withstand the extreme temperatures of the corona. The recent double calm cycle of the Sun is a bit concerning when trying to predict how active the Sun will get this cycle. The sunspots completely disappeared for a long time from the entire surface of the Sun. It is as if the magnetic distortions we usually see on the photosphere of the Sun had collapsed into its interior. Intense magnetism is coming to the surface now and breaking through into the corona. The National Center for Atmospheric Research in Boulder, Colorado, is predicting that this solar cycle, cycle number 25, will be one of the strongest ever. The last solar cycle was very calm, with a sunspot count of only 116. The average is 170. But the prediction for this cycle is between 210 and 260 sunspots, which would be one of the strongest cycles ever. We stand to lose more satellites to a stronger solar wind. We can also expect electric grid overloads as the proton storm peaks in 2025. That means we should expect an interruption to our internet services as positively charged protons get into the wires, run into the transformers, and overload them. On March 12, 1989, a powerful CME hit Earth and created absolute havoc with our power grids. Will we experience anything of this magnitude in the near future? Well, stay sharp, Brightsiders.